Hello students, welcome back. Today we'll continue with the third video lecture of chapter number 2, that is electrostatic potential and capacitance of NCERT. Okay, so today we'll start with the topic electrostatic potential due to a dipole. Okay, in our last video we had studied about electrostatic potential due to a point charge, due to a system of charges, and due to a uniformly charged spherical shell. Okay, so now to find out the electrostatic potential due to a dipole, let's consider a dipole like plus Q and minus Q. Okay, distance between these two is 2a. Okay, now let's find out the electrostatic potential at a point P. Okay, let the position vector of P from positive charge be R1 and from negative charge be R2. So the distance from positive charge to the point P is R1 and from the negative it is R2. This be the center. So this distance will be A and this distance will be A. Let the angle made by the dipole to this point P is theta. Clear? Okay, now we have to find out the electrostatic potential due to this dipole at point P. Now, what was the formula for electrostatic potential? KQ by R. Okay, so now see the potential due to plus Q will be V plus will be equal to KQ by R. And the potential due to, let's say, R1, okay, potential due to minus Q will be equal to K into minus Q upon R2. So the total potential at point P, V will be equal to V plus V minus. So KQ is common in both, 1 by R1 minus 1 by R2. Okay, so let's name this equation as equation 1. Okay, so this is the first step. We have reached that the potential at point P will be KQ 1 by R1 minus 1 by R2. You can also take 1 by 4 pi epsilon 0 instead of K. Okay, now what we will do, we will find out the value of 1 by R1 and 1 by R2. Okay, now from the geometry of the figure R1 will be equal to A plus, see, let's take this distance as R. Okay, let's take that distance as R. So R1 square will be equal to A square or R square plus A square plus 2AR, sorry, not plus, minus 2AR cos theta. Okay, now how did I get? You can take different methods like vector addition. The angle between two vectors will be 180 minus theta. Okay, or else you can take cosine rule. In mathematics, you might have studied in standard 11. If this is A, B, C, sides are like this, opposite to A, B, C. If this is theta, then according to cosine rule, cos theta will be equal to A square plus, sorry, not A square, B square plus C square minus A square upon 2BC. Clear? So here, if I take this triangle, this angle is theta. So what will be cos theta? Opposite angle, that is R1, that is A. So A square plus R square minus, minus R1 square upon 2AR. So 2AR cos theta equal to A square plus R square minus R1 square. Taking this here and this on this side will be minus. Clear? So by the geometry you will get this formula. Okay? No need to derive this. It's only for the information. And similarly, I will get R2 square equal to R square plus A square plus 2AR cos theta. Because in this case, this angle will be 180 minus theta and cos 180 minus theta will be equal to minus cos theta. So it moves on this side, it will be plus. Okay, so these two equations, let's name this equation as 2 and this as 3. Now we will take only one equation and solve it completely, find out 1 by R1. Similarly, we'll find out 1 by R2. So equation 2. R1 square equal to R square plus A square minus 2AR cos theta. Okay, so now let's divide it or let's take R square common. This will be 1 plus, I can't take common here, so I'll divide by R square minus 2AR upon R square. So it will be 2A by R cos theta. Now see, multiply r square into 1, r square into a by r square gets cancelled, a square, r square into 2a by r, 1 r gets cancelled, so r2a r cos theta. Clear? So I got this value of r1 square. Okay, so now what we want, I want 1 by r square. But now if r is, see here, this is the distance r, okay, and this distance is a. So this distance, if it is very small, it will be negligible compared to r. So we can ignore this. When r is too much greater than a, then a square by r square is negligible compared to 2a by r cos theta and 1. So r1 square will be equal to r square, okay, let me erase this, into 1 a square by r square negligible minus 2a cos theta by r. Okay, I'm writing this equation, I'm carrying it forward here. Okay, so that will be r square, sorry, r1 square will be equal to r square into 1 minus 2a cos theta by r. Now see, I want 1 by r1 and I'm having r1 square. So first I will take square root. So r1 will be equal to r 1 minus 2a by r cos theta whole raised to 1 by 2. Square root square, it get cancelled. So again square root square, but here we are taking 1 by 2 because here it's not square. Okay, now I want 1 by r1, so reciprocal 1 by r1, this will be equal to 1 by r. Instead of taking in denominator, what I will do, raised to minus 1 by 2. Okay, so I'm not taking it in denominator, I'm taking the power minus 1 by 2. Okay, now if I apply or using binomial expression, okay, now see what will be that if it is like this, a plus b by c whole raised to n. Okay, and if B is too much less compared to C, then this will be equal to A plus NB by C. Okay, so similarly, what will happen? This power will come here. So using binomial expression, 1 by R1 equal to 1 by R, 1 minus 1 by 2 into 2A by R cos theta 2 gets cancelled. Okay, so now this will be minus minus plus. What we did using binomial theorem, I had put this minus 1 by 2, I had taken here. Using binomial theorem, okay, this power will be here. Okay, so this will be 1 by R1 will be equal to 1 by R, 1 minus minus plus A by R cos theta. Clear? Now, similarly, if I will take this equation, similarly, from equation 3, we get 1 by R2. This will be equal to 1 by R into 1 minus A by R cos theta. Here it was minus, I got plus. Here it is plus, I will get minus. So now I got the value of 1 by R1 and 1 by R2. Putting in equation 1, what I am doing? I am putting the value of 1 by R1 and 1 by R2 in equation 1. So I will get V equal to KQ. Okay, 1 by R minus means I will subtract these two. So 1 by R and 1 by R common. 1 minus 1, 0. A by R cos theta minus A by R cos theta. So it will be plus. So this will be 2A by R cos theta. Clear? So see what I got. I got V equal to K 2AQ cos theta by r square. Okay, so what is 2AQ? Okay, product of distance between two charges and the charge is dipole moment. So we will be equal to Kp cos theta upon r square, or instead of k I can write it down 1 by 4 pi epsilon 0 P cos theta upon r square. This is the equation of electrostatic potential of a dipole, or electrostatic potential of an electric dipole. Okay? Clear? So this is the equation. Now, can I take P cos theta equal to P dot unit vector R? Value of unit vector is 1. So P into 1 into cos theta, this dot product. So I can also write it in this way. V equal to K P, or let me write down 1 by 4 pi epsilon 0 P dot R by R square, or Kp dot R upon R square. Clear? Okay, so this was the formula for electrostatic potential due to dipole. Now, taking different cases. Okay, when I take different cases, like when I take theta equal to pi by 2, when theta is equal to pi by 2. So what is the value of cos pi by 2? 0. So the potential will be equal to 0. Say, what happens? In which case the theta will be pi by 2 if it is in this way. So this distance will be same. So potential to plus will be equal to potential to minus. But one will be positive, one will be negative. So resultant will be 0. When theta is equal to 0, 0. Okay? Means if it is in this way or this way, 0 or 180, at that time, what is the value of cos 0? 1. So it will be kp by r square. Okay? Or 1 by 4 pi epsilon 0 p by r square. If it is 180, it will be minus kp by r square. So potential is maximum on the axis of dipole and it's zero on the equator of the dipole. Clear? So I'm repeating the whole topic once again. Our aim is to find out the electrostatic potential due to a dipole. So let as shown in figure, there is a dipole, distance in both the charges 2a, and let's find out the electrostatic potential at point P. Okay, so you can write down here from figure, let's find out electrostatic potential at point P. Okay, so now potential to plus charge Kp by R1 minus charge Kp by sorry Kq by R1 due to positive charge, Kq by R1 due to negative charge minus Kq by R2. So the total electrostatic potential will be V plus V minus. I will get this formula. Okay, this is the first part. Now, next, to find out 1 by R1 and 1 by R2. So, by taking the geometry of the figure, R1 square will be equal to R square plus A square minus 2AR cos theta, and R2 square equal to R square plus A square plus 2AR cos theta. Now, we will solve only one equation, and similarly, we will find out the value of, we will write down the value for second. So, from equation 2, what I did, I took R square common, okay, A by R square, negligible, okay. So here, let me write down this way. A square by R square. Actually, A by R is negligible. So A square by R square is also negligible compared to 1 and 2A by R cos theta. Okay. So now, taking this, taking square root, reciprocal, and using binomial theorem, finally I get 1 by R1 equal to 1 by R, 1 plus A by R cos theta. And similarly, 1 by R2 will be equal to 1 by R, 1 minus A by R cos theta. Putting these two values in equation 1, finally I got V equal to Kp cos theta by R square or 1 by 4 pi epsilon 0 P cos theta by R square. We can take P cos theta equal to P dot R. So what does this imply? V equal to 1 by 4 pi epsilon 0 P dot R, unit vector R upon R square or Kp dot R upon R square. Okay, now two cases. Case one, when theta equal to pi by 2, the potential will be equal to 0. Means at any point on the equator of the dipole, equator of electric dipole, the potential is 0. And at any point on the axis of electric dipole, when theta is 0 or 180, it will be maximum. Means minus kb by r square or plus kb by r square. Okay, so note down this topic. Okay, students, so that was for the electrostatic potential due to an electric dipole. Okay, it's electric dipole, right? An electric Dipole. It is very important. This question can be asked in 4 marks. Okay, so that's it for today. Thank you.